Hello, welcome to another episode of With the Easy. Today we'll try to use ChatGPT to generate this 3D interactive plot shown on the left side here. And as discussed earlier in this Jupyter notebook, you can actually change the camera angle of the 3D plot. You can also zoom in, zoom out. There are also hover information, which is sometimes very useful in the explanation phase of your data visualization. And more detailed discussion about all the functions I have just briefly shown you can be found in this Jupyter notebook under DV4C Interactive Plot Part 2. And I just opened the Jupyter notebook in a website called MB Viewer so that this part of the 3D plot is interactive, because I don't think that's possible in GitHub default opening format. While this is loading, I can also introduce a little bit about the raw data used today. Well, the raw data we use is also from DV4C channel or GitHub repo, and it's under this LCMS data folder. We will use all three CSV file here. We have the LC data, we have the mass spec data, and we will also use the timestamps for each fractions in the LC data. So this is just showing that you can get pretty much the same static information, including GIF. If you open the Jupyter notebook in GitHub, it won't allow you to see this interactive plot as we saw right here. So without further ado, let's jump right in. I already make a Jupyter notebook for today's topic, and the raw data have been downloaded in the download folder. We have ChatGPT here. Hopefully, it will guide us through a smooth reproduction of the plot. So first thing first, we'll need to read in the 3CSV raw data, and we'll also need to take a quick look at their data structure. So let's do that. Okay, now we're reading the three raw data here. So df underscore ms is our mass spectrometry data. The underscore LC data frame is the LC data, and the underscore time is the timestamp. As we can see from the top 5 columns from each data frame, the mass spectrometry data, we have 4 columns. We have a fraction number column, the absolute mass, the counts, and the relative mass. In the LC part, we have 2 columns. That's the time and the UV signal. And in the timestamp, we have 3 columns. We have the fraction number and the start and end timestamp for that fraction. And we're trying to reproduce this plot where if we go back here, where we can tell that we have the LC data plus the timestamp on the YZ plane, and in the 3D place, each XZ plane is a mass spectrometry trace from this data frame. So let's describe our problem set to ChatGPT and see whether he can help us. All right, here is our description of the problem. It's pretty long, but I basically describe the data frame as well as what we want to do to ChatGPT. And let's see what we got. Yes. Okay, sorry for the hiccup. Let's take a look at the plot generated here. Looks like we got pretty much what we want to reproduce with some caveats here. Obviously, there's this rainbowish color for all the mass spectrometries, which I think is more destructive than helpful. Also, when we take a look at the plot we have on the left side, it was very clear that the x-axis or the relative mass was in a much smaller range, and the LC data got plotted at the leftmost instead of at the x equal to 0 YZ plane, as ChatGPT did it on the right. So we can definitely fix that. Um, and also, I like to bring back the background color to the plot. Let's see whether we can have ChatGPT do that. Okay, now I described all three requirements. Let's see what we got from ChatGPT. All right, let's copy that. Here we go. So it looks like it fixed the x-axis range and also the LC data. But there's this retention time range, which is much narrower in our original plot. So let's do that. And I also want to bring back the original background color from Plotly. Okay, here are the code we got from ChatGPT. I'm still populating. Let's copy the code and give it a try. Looks like we fixed the retention time range, but the background color is still blank. Let me give ChatGPT another prompt. All right. Hopefully this should store the default background color from Plotly. And we copy the code. There we go. It looks pretty nice now. The last thing we want is the drop lines of the fractions. So let's add that. Okay, I gave ChatGPT a pretty detailed description about what we want about the drop line, including the Z range. Let's see what we got. So now we copy the code and let it run. All right, this looks not bad. It looks it pretty much satisfies all our requirements. If I move that a little bit. Yeah, and when we compare this with our original plot, it's pretty much the same except maybe the axis label and also the color choices. But other than that, they look pretty much the same. I'd call this a successful reproduction, and that pretty much marks the end of our episode today. If you like this session, please make sure you press the like button. If you have any questions, put it into the comments part. And sharing is caring. So if you find this helpful to you, maybe consider sharing that with your friends. And with that, I want to thank you all for watching this episode of With Easy, and I will see you all in the next episode. Enjoy.